I always encourage you guys, especially if you are preparing for your CCNA certification or definitely in the field of work. From what we are doing, definitely you will benefit from what we are doing during these sessions. You only have to have the time. Like if you are part of the group, always be aware we have already created a drive. You can have access to all the links, the materials, the window modern books, all the volume 1, volume 2, they are all in that particular drive. You only need to have access to the drive. Then at the same time, all some of the PDF files I have created, I have already created a nugget PDF files. You can have access to all these materials through the drive. I saw earlier I will try to reshare the drive, but if you go up and check, you can see that particular link. Just click on the link and have access to all the materials. At the same time, I encourage you all you guys to make sure that you install Packet Tracer in your PCs. Make sure that at least what we are doing, you try to implement it. The whole thing about networking, the whole thing about routing, switching is about doing labs. So if you see what we do during the session, have time, try to do your best to make sure that you try to replicate the same lab. Click and drag your network devices in Packet Tracer. That's why Packet Tracer is a simulation. I recommend Packet Tracer. With just Packet Tracer is enough for you to practice for your CCNA exam, and at the same time you can implement a lot of stuff, because based on the latest update with Packet Tracer, you can do a lot of there's a lot of commands now we can able to implement. So take advantage of that. So please, so now as always, let me try to share my screen with you guys. This is a basic lab. Based on this basic lab, we will develop more labs. I just want to start to encourage you guys before we start to use more advanced labs. This is just a basic lab that I want you guys, after implementing today's session, for you guys to replicate it in Packet Tracer. Try to do it. Packet Tracer is all about labbing, and the exam or even the field of work is all about practical. You need to know the practical. When you are at the field, you're able to implement it. So I encourage you guys to please do your best. Try to install Packet Tracer in your PCs. Try to replicate the same stuff, the same lab. The Packet Tracer lab will be available, or if best, you can just look and try to click and drag everything, start it, try to build it from the ground. That will resonate with you more and more than just using the Packet Tracer you to start doing configurations. So in today's edition, we need to know about, if during this lab you can see we have 3 switches. These 3 switches with a 1 router. Now we have 3 PCs. This router here is between segmenting and moving traffic from one session to another session. If you can see within this, we have the 10.0/10.0.0.0/8 here. Then we have the 192.168.10.0/24. Then in this other side, we have 172.16.20.0/16. Okay, so now for this session to be interactive, guys, I need your operation too. So during this side, if you look at this side, we are using the 10.0.0.0/8. So what is the subnet max for this particular network?
255.2 255.0.0.0
255.0.0.0, because we are using a CIDR of /8. So now if we move to this other side here, we are seeing /16. This network here indicates /16. What will be the subnet max that will apply to the PCs, all the PCs that are in this particular network?
255.255.0.0.
Perfect. Based on /16, meaning all the PCs here, we need to implement 255.255.0.0. Now we move to /24. In this /24 network, what will be the subnet max?
255.255.255.0.
Perfect. 255.255.255.0, because this is /24. So now we already know with /8 here, this network with this /8, we have over 16,777,224 IP address, valid IP address at our hand. So if you are implementing /8 within this particular network, you have more IP addresses to allocate to PCs within this particular network. So now, if we move to this /16, we are what? We have over 65,534 valid IP address within this particular class. Now within this class, now this /24, who can tell me how many IP address we have, valid IP address we have within this?
254.
254 valid IP address here. So now, if we see 10.0.0.0/8 here, which class is this?
Class A.
Class A. So now if we see 192.168.10.0/24, which class of IP address is this?
Class C.
Class C. Whilst the 172.16.0.blah/16, so that we will now know that it's a class B IP address. So now that you are aware of the IP addresses, you need to know, after looking this diagram, we can see that we have PC1, PC2, and PC3 now with a router here. But when you see, by default, switch interfaces, they are up by default. Whilst router interfaces, they are down, administratively down by default. That's why between PC1 to switch 1 here, you are seeing the interface is green. While between switch 1 and R1 here, the interface is down. This tells us that every interface within a router, by default, it is administratively down. We need to power that particular interface for the interface to be running. But at its stand, when you have a router, always know that all the interfaces by default, they are administratively down. So now our objective for today's lab, our objective is this. 1. Configure R1 host name. This is R1. R1 by default, when you open routers by default, the default name they come with is routers. It is not advisable for you just to configure IP address or do any configuration within a router with that default name. It is advisable in any company, they have their own skill, they have their own way of giving some names to their devices. So you need to follow those rules. So now we need to change this R1 to R1 host name, not just the router by default. So in the second phase, use show command to view a list of router interfaces, their IP addresses and status. Now, after changing the router name here, our second move is to execute or use a command show IP interface brief, so that we need to have access to see the interfaces. Now we can see the G0/0, G0/2, G0/1. These are all interfaces connected to this PC, to this particular router. But you can't just configure IP address or on these interfaces without executing a command to see what is already running or what is already been connected to this particular interfaces. So you need to be aware. After having access to a router, if you want to do some changes, make sure that you execute command to confirm before you do any changes, especially in production network. Don't do changes without first knowing what the changes, the type of changes you want to do to that particular device, and verify before you do a changes. So our third step will be configure the appropriate IP addresses on R1 interfaces and enable the interface. Configure appropriate interface description. You see, in step 3, now we need to assign IP address. We need to configure IP address in these interfaces, the G0/0, the G0/1, and the G0/2. At the same time, we need to enable the interface, meaning the interface is down. So to enable it to turn up, then from the same time, then we need to add description to these interfaces. Adding description to interfaces is very, very essential, and I encourage or advise every engineer to always try to do these things. Because now, if we add description to this interface, G0/0 to switch 1, let's say for an example, G0/0 is connected to switch 1. So if you add description, interface G0/0 is connected to switch 1, definitely when troubleshooting, when you have issue, if you execute your command, you give your show run or you give your show interface, definitely you will know, you can able to troubleshoot very, very easy to dictate this interface because you have already added a description to this particular interface. So it is advisable to implement description to interfaces, especially when doing troubleshooting. Our next phase is use a show command. The fourth step is use a show command to verify R1 interface again. Now we have configure R1, change the default name to from the default name to R1, assign IP addresses to this interface, turn the interfaces up. After doing this, your next phase is verify your work. 4 is about verifying. Verify the changes you have done to that particular network device. Don't just configure IP address in any network device or do any changes in a network device and just leave it that will just save your work. No, it is not advisable. Verify your work after doing any changes for you to see what you have done, then you can save your work. Now step 5 is view the running config to confirm the configuration changes, then save your configuration. So step 5 we will do what? After verifying the changes you have done within this particular router, your next what? Now we can execute show run. When we say show run, during the time you are operating, during the time you are executing command, during the times you are doing some configuration within any network device, you are in the running config, the actual config. So after that running config, what you have changed or the configuration you have done within that particular running config, you can now save. Why? Because when you save, for the next time when that device is booting, it will boot from the startup config. And booting from the startup config means the configuration you save, the device will boot with it. That's why after doing the configuration, it is advisable to save your work, because for the next time when you reboot, the device will pick from what you have saved. Then our sixth step today is configure IP addresses on PC. This is supposed to be on. I think I make a mistake here. On PC1, PC2, and PC3. As you can see here, PC1 have PC1, PC2, and PC3. We need to assign these IP addresses to these PCs. Then the 7th step is what? We need to pin from PC1 to PC2 and PC3 to test connectivities. After doing all our configurations for today, we need to verify our work. Now try to do a pin. PC1 supposed to pin PC3. PC1 will able to pin PC2. After doing all this configuration, the pin, if the pins go through, meaning we have succeeded in the configuration. So now let's start the configuration. Our first step is to click. You click on the router. Sometimes when you click on the router, you will see this, something like this, the network, the device itself. So you need to go to what? Click on the CLI. Now when you click on the CLI, you can now see the CLI, press enter. You see our first, by default, you can see router. The name is router. So our first option for today is to change this name to what? To change the name to R1. So changes this name we have from our previous sessions. If you are following up, or please try to look the previous session. This we have modes. We have the user mode, privilege mode, exec mode, interface mode. We have different modes when you have access to the CLI. So you need to know the different modes. We have already covered that. So I don't want to spend too much time on that. Now from here, our first mode is enable mode. We need to move from this enable. with this command enable mode, press enable mode, definitely you can see now in user mode you see the greater than sign. Now from that, when we move to the privilege mode, you see something like this number sign. Now we are in a different mode, and this mode is more higher than the user mode, but we can't do the router changes within this mode. We need to go to the global configuration mode. When we are in the global configuration mode, you can now able to change this name, the name of this router, from the default to R1. So we move the command is config terminal. With this config terminal, some will just abbreviate config T. You can use config T, it will take you to the global configuration, or config terminal is the same thing. We have already done all this from the previous sessions. So within here now, you can see we are now in the global configuration mode. Now from this mode now, we want to say host name. The name of the host, we say R1. R1, press enter. After pressing enter, we can now see there's now the changes. This name, this default name we are seeing, which is router, has now changed to R1. So you see, so our first task objective for today, configure the R1 host name, we have done that. So our second is use show commands to view the list of R1 interfaces. Now, within R1 now, we have changed the name, but before you do any changes, they ask you need to verify, you need to know the interfaces you are working on. The command, we have two ways to execute this command. I'm in the global configuration mode. You can be in the global configuration mode and execute the command, it will work. At the same time, you can able to exit out from the this global configuration mode, go to the privilege mode, you can execute the same command to see the interfaces, to verify the interfaces before we implement any IP address on it. It will work. So, but if you are in the global configuration mode, for you to execute that command, you need to use the word do. This first. Now you say do show IP interface brief. With this command, take note I'm abbreviating. You can see the show IP, I abbreviate the IP address, and the interface, I abbreviate it. The brief is I just abbreviate BR. From our previous session, I've shown you the full commands. So we said we press enter. After pressing enter, now see, we can now see that in R1, after executing this command, do show IP interface brief, we can see the interfaces in R1. These are the interfaces. We can see the gigabit interface G0/0, which is C under IP address unassigned. There is no IP address assigned. It is okay. The status for this particular interface is administratively down. So you see by default, as I earlier mentioned, this interface here we are seeing G0/0 interface. See G0/0 interface here is administratively down, no IP address assigned. G0/1 interface. This G0/1 interface here, we are seeing this G0/1 interface here. What it says, see, no assigned IP address, now administratively down. So you see the G0/2 interface also. The G0/2 interface is connected to this network. G0/2. You can see the G0/2 network here. It is down. You can see the red signal. So now we have verified show the interface, but we implement the do, right? We can exit out from here. We can exit from this interface. When you exit, it will take you back to what? To the privilege mode. With this privilege mode, I don't need to, I can execute the same command but without using the do. We just show IP interface, brief. You see, I can execute the same command, show IP interface brief. I didn't use the do because I'm in the privilege mode. Privilege mode, you can see the sign. There is a great changes here. Global configuration mode, you can see the signs is different. It says config. So now it's the same thing. So we have verified, we have seen our interfaces. The interfaces, they are all in the router, but there is no IP address assigned to them. They are all administratively down. So our next option, configure the appropriate IP address on R1 interfaces and enable the interfaces, configure appropriate interface description. So now we need to configure the interfaces. Now, to configure these interfaces, let's start with the interface G0/0, this interface G0/0. Before you configure an interface, you will make sure that you are in that particular interface before you assign an IP address on that particular interface. You can't do it. Make sure that you are aware that I'm in this interface and this is the IP address I need to assign to that particular interface. Please take note of this. So now we need to move from the from the privilege mode now to config terminal, config T. Now from this config T now, you need to go into interface, which interface? G0/0. Interface G0/0. Then you press your enter key. Now we are now in the interface mode. As you can see, config IF. This is config IS, guys. So now within this config IS now, what? You are now in this interface G0/0. So any changes you do here will affect this particular interface. So you need to be aware of the changes you are making. So now we want to assign IP address. We say IP address. The IP address now, we are using this IP address, the 10.0.0.1. 10.0.0.1. So now with the 10.0.0.1, we already know this is a class A and the CIDR is class 8. So the subnet max now is 255, as you guys earlier answered, 0.0.0. This is now an IP address 10.0.0.1 255.0.0.0 because it is class A. Now we have assigned the IP address to this particular interface. Now we need to turn on, we need to tell this interface to come up because the interface is administratively down with the command no shutdown. Now as you can see, if we give spanning tree some seconds, definitely you can see this interface both will turn up and running. Don't worry about spanning tree. I've already created a lab for spanning tree based on spanning tree for you guys. You will cover it. Spanning tree is very, very essential for our networks today. So now you see the interface is now up, but spanning tree is doing its thing here. Let me say, I believe in 25-second time this is supposed to turn to green. Okay, so now here now within this interface we need to add description. Someone want to say something?
I said
okay,
it already has.
Okay, perfect. So now as you can see here now we need to add description to this particular interface because we want, if there's any issue within this particular router, we need to know this interface where they connect. Because take note, after you have mounted these devices in that rag, you have connected a lot of cable work. So if you don't have some description, you will find it very, very difficult to troubleshoot. So now let's say for an example, to add description onto this, you say description, the command is description. I will say connected to SW to switch 1. I will say this interface is connected to switch 1. See, I'm done with this interface. Now I can just exit from this interface. Bingo, we have done with this interface. We have turned on the interface up, we have assigned our IP address, and we have added the description into this interface. So now we move to the other interface. The next interface is G0/1. Make sure that, please, make sure that after configuring your IP address, you have turned off that particular interface, you have added your description, exit from that interface. Don't assign another IP address, because for any changes you do, it will affect this particular interface. As you can see, I've just used execute the command end. Now I can take the same route. I can use the same route, config terminal. From the config terminal now, I want to have access to interface G0/1. Within the interface G0/1, now I'm in G0/1, and now you can now assign IP address, which is 172.16.0.20.1. Now we say IP address 172.16.20.1. Now take note of the default, the subnet max for that particular network you implement. Our network, our subnet max will be 255.255.0.0. It is /16. So press enter. We say no shut down. I can just execute short like this. No short. It will turn, the interface will come up without even complete it. If I press the tab key, it will complete. It doesn't matter. So press enter. Now you can see the interface is up from the router side. Now the switch side is doing some spanning tree. After some 30-second stuff thing, 10, some 30-second stuff, definitely that interface will be forwarding traffic. So now let's add description for this interface. The description connected. This interface is connected to switch 2, SW2. See, you press enter. Now we move to the next interface. You see, for beginners, you need to exit from this interface. But as professionals, I can be in this interface. If I say interface G0/2 here, if I press enter, this will take me to interface G0/2. If you already have experience working doing configurations. But if you are just beginner, make sure don't implement this for you not to mistake, because you are presently in the G0/1. The best practice is for you to execute, to move out from that interface. Now you can go into interface G0/2. Now you press enter. Now we have exit from this interface, which is G0/1. Now we have go into the G0/2 interface, which is this interface. So now the IP address, we need to assign IP address to this interface. The IP address is 192 IP. We say IP address 192.168.10.1. We add our subnet max. Our subnet max now is 255.255.255.0. So now we press enter. Now the interface will have assigned the appropriate IP address and subnet max for that particular interface, which is this interface you are seeing here. This interface, which is the G0/2. Now, but the interface will need to tell the interface nigga come up. Say no short man. With this command now, you can see this interface is up and spanning tree is doing its thing in the switch side of things. So now we need to add description for this interface. We say description connected to SW3. Connected to SW3. So now we can end. When we end now, you can see the console have take us to privilege mode. So we can now see all these interfaces. They are now up and running. We have changed the router name. We have first verified our interface. Now we have done what? We have assigned IP addresses to this interface, and they are all up and running. I think that's okay. Configured IP address, interface, enable, configure appropriate interface description. We have done all this thing. Now the fourth step is use a show command to verify R1 interface again. Perfect. Always verify your work after every changes. Don't just leave it like that. Click now to verify. We need to verify our work, the changes we have made, if it have applied to the interfaces. The command is show IP interface brief. You can see, as you can see now, we are in the router, we are in R1, we have executed this command show IP interface brief. Now the interface, you can now see the G0/1 interface have an IP address 10.0.0.1. Now the interface is up. Same thing, G0/1, the IP address is assigned and the interface is up. The same thing applies to G0/2 and IP address assigned and the interface are all up. So we have assigned and we have verified. We are now sure that the changes we have done changes to these interfaces. So our next step is view the running config to confirm the configuration changes, then save the configuration. View the running config. So now within this, you need to execute a command to see the running config. When we say the running config, now as you guys are seeing this, we are presently, I'm scrolling, we are presently in the running config of this particular router. This is the running config. Every changes we are doing, we are in the running config. So after doing these changes, let's just see all the changes we have done within this particular. The command is show run. With this command, show running config, press enter, you can now see some changes. Show running config. You can see now from here, host name. We did these changes. Host name, we have changed this host name to what? To R1. Now you can see, if you press the space bar, these are some of the stuffs. Now we did these changes. Interface. We can see now interface G0/0, description connected to switch 2. You see, pretty easy. So if you just run that show run command, you can see all the changes you have done physically, how you did it. You see, so now the description for this interface is connected to what? This interface is connected to switch 1 without even having access to your network devices. Let's say you have just have access to this device through SSH or Telnet. You understand? You don't even have time to go to your MDF. So just with this command now, you can see everything. You already know switch 1 and the R1 interface G0/0 is connected to SW1. The IP address assigned to this particular interface is this. So now the interface G0/1, you can see the description, the interface G0/1 is connected to switch 2 and the IP address assigned to this interface is this. Duplex and speed, we can talk more about that when we start doing Ethernet. We move to this interface G0/2. You can see the description connected to switch 3, the IP address assigned. See all this. You can see now the end. We have more configurations. So now we have done this. So let's check our guide. Say configure, view the running config. So our option, okay, yes, our perfect. Our sixth step is configure IP addresses of PC1, PC2, and PC3. Perfect. So now, as you can see, we have assigned IP addresses to these PCs. But now, if this PC want to communicate to any other network, this PC particularly need to have what? Have an IP address to communicate. Because the IP address we allocate to these interfaces, we call this this PC will use this IP address to communicate to the other PC to the other network. So how do we call this the IP address assigned to this router? Anyone?
As the gateway address.
Perfect. That's the gateway IP address now. Now let's say PC1 want to communicate to this network or this other network. PC1 need a gateway to go to any other. As from our previous session, when we say the router is there to do routing for both inside and outside, now this switch is just for LAN, but when the packet move, when the data move now to the switch here, now the frame move from this switch now to what? To the router. Now the router will forward the packet. Take note of all the terms: data, frame, packet. So you need to be aware of all these terms, all these words: data, frame, packet. So now we need to assign this, because this PC can't just communicate outside here without having access to this gateway. So now we click on PC1. After clicking on PC1, we go what? We go to config. We go to config. After going to config, your first step is to assign the default gateway. Which gateway? This gateway you assign to this particular router. You need to take this gateway here, assign it to your PC default gateway, because the PC will use that gateway to communicate outside. So now the gateway IP address is 10.0.0.1. Take note, this IP address, this PC IP address is 10.0.0.5, but the gateway, this gateway here, you assign it. Now we go to the Ethernet, fast Ethernet 0. You click on this fast Ethernet 0 now to assign this PC, this IP address to this particular PC. So now the IP address now is supposed to be what? We say 10.0.0.5. So now this is the 10.0.0. Now within here now, the subnet max now. Take note, the same subnet max you assign to the gateway supposed to match with the IP, the same gateway for this PC. So by default, if you click here, it's supposed to show up. You see, without even typing. Now, without even typing, by default, the 255.0.0.0 just come up, because this octet starts with class A. I know that you guys already know this from our previous. Now, from here, we have done with this, with the power of packet tracer. You don't need any OK for saying you have OK button to press. As after doing configure, just close. Automatically, the configuration will become effect. So now we move to our second PC. The second PC is this, PC2. Now you click on PC2. We try to assign IP. So now from this physical, we move to what? What will be our next step? We move to what?
Config.
To config. We click on config. After clicking on config, the first thing we need to do is what? We assign our what?
Our gateway address.
We assign our default gateway IP address. This gateway, the IP address you assign on this interface, this router interface, you need to assign it here, because all the PCs, all the 65,000 PCs within this particular network, they will all use this particular IP address as gateway to communicate outside. So you assign it, telling them that use this IP address to communicate outside. That's your roadmap to have access to the internet. Now we say 172.16.20.1. Now from here, for me just not to keep typing this, I can even copy this. Now we go to the fast Ethernet. We click on the fast Ethernet. When you click on fast Ethernet 0 now, you can now able to assign this IP address, which is 172.16.20.15. Now you click. If you click, I just want to paste it. Now then add 1, which is 15. Don't get confused. You can see this is 172.16.20, which is 172.16.20.15. the IP address to assign to this particular PC. After assigning it, if you click down here, by default it will automatically come up, because we are starting it with 172, which is a class B network. Now we have done with this interface. Now our next step is the class, this PC3, the third. Perfect. So now we click on PC3 here. As always, guys, let's do this. So our next step is what? The config. Okay. From the config, we move to what? What we need to do?
We enter gateway.
The default gateway. Now we need to assign the default gateway. This, as always, this IP address, use 192.168.10.1. This is the default gateway we assign. This is the IP address we assign to this particular interface. So we need to assign this particular IP address to the default gateway. So now we say, let me just see this. We say 192.168.10.1. This is the default gateway. I can copy this IP address. Now we go to the fast Ethernet 0. Now fast Ethernet 0. Now we need to, under fast Ethernet 0, now that's the IP, we need to assign now the particular IP address which is unique to this network. This IP address, which is 192.168.10.10. We need to assign now this IP address 192.168.10.10. You see, you press down here for your subnet mask. Automatically the subnet mask will come up, which is the /24 subnet mask. Now we have assigned the IP addresses to PCs. See, blah 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 blah. Yes, IP address for PC1, PC2, PC3. So now, which is all set. Now our seventh step is pin from PC1 to PC2 and PC3. So PC1 needs to pin PC2 and PC3 to see connectivity. From this side, we should able to pin PC2 here. We should able to pin PC3. If the pin fail, meaning we have issue with this configuration, we need to do some troubleshooting. But if the pin is successful, bingo. So now let's try to test. Let's try to pin which network? This PC2 172.16.20.15. Now you click on the PC. After clicking on the PC, you go to desktop. You click on desktop. After clicking on desktop, you go to command prompt. You click on your command prompt. You see, Packet Tracer is really good simulation. We can now see the command prompt. Now we want to pin from PC1. You can see up here, PC1. Anyone, you want to say something?
Hello, good evening.
Yeah,
Really want to let you go back small from this point so that I will get clear and other colleagues themselves will get clear from this point.
Okay, so now as you can see, now we have done the configuration on the PCs. We have assigned IP addresses to the PCs here. PC1, PC2, and PC3. We have assigned IP address. But now our next option here is pin from PC1. PC1 need to pin PC2 and PC3. Now for what we see, we need to show that connectivity there. There's a connection flowing from PC1 to PC2, from PC1 to PC3. So we need to test connectivity. If there is no connectivity, meaning we need to do troubleshooting on this lab again. But if there's if the pin is successful, bingo to the network. So to pin this, the first thing you need to do, you need to click on PC1. After clicking, by default, when you click on PC1, in the first phase, when you click on PC1, you will see PC1 like this. Now you need to move to the desktop. Come to this desktop. You click on desktop. After clicking on desktop, now you go to command prompt. You click on your command prompt. Now, after clicking on, you can now see the command prompt. Within this command prompt now, we need to try our connectivity. But we want to pin this IP address, which is PC2 IP address. The command is ping, we say ping, P-I-N-G, ping 172.16.20.15. Guys, please mute your mic. Please mute your mic. Thank you. So now, as you can see, we have, I just don't want to mute everyone's mic. So please, after communicating, just mute your mic. So now, we have typed the pin. We are now pinning 172.16.20.15. Now we need to press enter. So now, you can now see we want to pin to try our connectivity. 172.16.20.15. Now we need to press enter to see if there is a connectivity between PC1. Okay, so now guys, as you can see, our first pin records timeout. Our first pin failed, but the second, third, fourth pin was successful. As you can see, reply from 172.16.20.15. There's a reply from this. We pin this network, this IP address. Now we have a reply from, which is successful. So if you can read this down here, you can now see that pin statistic for this 172.16.20.15, packet sent was 4 packets sent, received 3 packets received, 1 packet lost. So now, if we try to pin it again, all 4 packets will be successful. I can now see all 4. Why this first packet failed? Okay, so now when PC1 try to pin PC2 here, the first packet failed, but the 3 packets went successful. When we try to pin it again, both the 4 packets were successful at the second phase, at the second pin. We have what we call ARP, ARP, Address Resolution Protocol. In every network today, sometimes the first pin will fail based on ARP. Why is ARP? Let's say for an example now, PC1 here is trying to send a message to PC2 here. Now, when the data move from PC1 here to PC2 here, the switch MAC address table is clean. The MAC address table of switch 2 is clean. There's no record in switch 2 MAC and switch 1 MAC address table about this IP address, or about this particular interface connected directly from this R1 to PC2 here. Switch 2 don't have any clue about that, and switch 2 survived by MAC address. So what will happen when PC1 send the packet? What will happen? Switch 1 will flood all the packet, will flood the frame. The term when in switch is frame. Switch 1 will flood the frame, asking, hey guys, I have a frame here, but the payload contains what? 172.16.20.15. But I don't know. If you have this particular IP address .15, please, I want you to respond with your layer 2 MAC address, so I can resend the original package. Switch 1 here will flood the packet. Now what will happen? This switch will receive that particular frame app message, but PC1 will not, because the packet moved from PC1. So only this frame. Now when the router receives that particular packet, now we are in the router, the name change now to packet, the router will flood it also, looking for what? For this IP address. Any network that have this particular IP address to respond with the layer 2. Now, what will happen? When the app message reads, the app message will return back to R1, go to switch 2, showing now the MAC address of this particular PC. Now what will happen? When the app is returning, when the message is returning, switch 1 now will save that particular MAC address, which is this particular interface, G0/1 interface, saving this MAC address, this G0/1 interface MAC address, telling us that if I want to communicate to .15, I need to use this exit interface to communicate to this particular IP address, which is .15. I need to use this exit interface to communicate outside. So, but because switch 1 don't have that first MAC address, knowing that this is the interface it needs to use to communicate to this PC2, that's why switch 1, that's why that particular first frame was dropped. So you need to know about app. So that's why this first PC was timed out. Let's take an example. We just want to see how the packet move now from simulation mode from this PC to from PC1 to switch 1 to the router to switch 2 and PC2. We can see the simulation. For we to see this simulation, you can see the simulation from here. Simulation, just click on the simulation mode here. If you click on the simulation now, we can now go back to our PC here. We want to test the connectivity again. If you press the up arrow key in your keyboard, it will bring because you already have an history on this. You press enter. If we press enter now, what will happen? We can see there's a packet. You see? There's a packet which is an ICMP packet. Now this packet now will move from this PC to where we want to see it now in simulation mode. You can see the packet is now moving from PC1 to PC2 to switch 1 to the router. You see, to switch 2 back to PC2 because we pin the 172.16.20.15. This tells us that yes, for every any users that are in this particular network, if they send any packet now, the packet will move to this particular network or to any other network. So now we go to real time. Our next is we need to pin from PC2, from this PC1 to PC3 here. Our PC3 IP address is 192.168.10.10. We click on this from PC1. We say pin 192.168.10.10. This IP address we are seeing here, the IP address we type is this IP address 192.168.10.10, which is PC3. So now we need to see if the pin will be successful. You see? So same thing. The first pin failed. Why? Well, because the first pin failed and the other three pins were successful. Why? Because now because in switch 1 here, switch 1 have no clue. This is the first time switch 1 is communicating to PC3. So now switch 1 needs to build its MAC address table. When we start using switch commands like show MAC address table, if we execute switch and that command show MAC address table, we will see the interface, the egress interface, but I don't want to confuse you guys. So now that's why the first pin failed, but the second, third to the fourth pin, they are all successful now to this. Now we want to see, let's try to pin now from PC2 to PC1. Now this is PC2, click on PC2. Take note at first, when you click at first, in every PC, you click, you can see this from config, you go to desktop. From the desktop, you go to the command prompt. Now from the command prompt, we say we want to pin PC1 to see now from different face. We say pin, command is pin 10.0.0.5. Bingo. Now the command is successful, but there is a takeaway here. Why? Now, as you can see, when we first pin from PC1 to PC2, we have the first pin fail. But when we try the second time, all 4 successful. But when we tried PC2, what happened? PC2 at first try, all is successful. Who can tell me why?
And I think because the communication is slow from PC1 to PC2, so already it also have what we call the cache. The cache has already been there in PC2 to communicate to PC1. So that's the reason. Thank you.
Perfect. So yeah, MAC address table has already been built. So they are all surviving now through. All PCs and all switches, they survive by MAC address table. But when we start talking about MAC address, we will know more about MAC addresses. I want to say, let's see if we have any other stuff down here. I think everything is good. Thank you guys for being part of this for being part of this network. Let's keep learning, let's keep pushing, don't stop, keep moving forward. No matter what opportunities, will definitely sign on one day. Let the opportunity meet you well prepared, so you will just grab it. Don't wait until you have the opportunity before you start learning. That's a big mistake. Let's prepare ourselves for an opportunity. When it arrives, we'll make good use of it. Thank you guys. Have a wonderful weekend.